Hey Kipsters, today we're going to be working on Module 4, Lesson 23, the defining equation of a line. Take 10 seconds to make sure your paper looks like mine. Make sure your heading is at the top, and let's get started. Our objective for today is that you'll be able to determine that two equations define the same line if the graphs of those two equations are the same given line. So we're going to be looking at equations in standard form and some equations in slope-intercept form, and we are going to plot them on graphs and compare the constants A, B, and C. Sketch the graph of the equation 9x plus 3y equals 18 using the intercepts only on the next page. I want to work through with you. Go ahead and butterfly your paper. Paper should look something like this. All right, please make sure that you have done step 1. Let's rewrite our equation at the top of our graph. I'm only going to zoom in on my graph page now. And our prompt asks us to use the intercepts only. So there are two intercepts we've learned about, the x-intercept and the y-intercept. With my given value to substitute into my equation in step 2, which intercept am I solving for first, my x or my y-intercept? You should be telling me that I'm solving for my y-intercept, so I know that step 1 is to rewrite the equation like I've been given. Then step 2 is to use substitution. So when I rewrite the equation this time, I'm going to substitute using parentheses everywhere I see an x. I'm going to replace it with a 0. Bring down everything else I didn't touch. So step 3 is where a lot of us are getting confused. Remember, step 3, once we've substituted, we always substitute to do some math. So I'm going to scan from left to right. I'm going to use PEMDAS, the order of operations, to determine what math to do first. I see multiplication happening between this 9 and this 0. I know that 0 times anything is 0, so that's going to be 0 plus 3y equals 18. I've computed all of the math that I can do. Now I'm moving into step 4, which is to isolate the variable. So the 0 is actually going to go away. So I'm going to rewrite my equation to say 3y equals 18. I want to use the division property of equality to undo the multiplication happening between this 3 and this y. So I'm going to divide both sides by 3. Once I've divided both sides by 3, 3's will cancel out on the left, and I'm left with my variable of y. And 18 divided by 3 leaves me with the value of 6. Well, I see an x and I see a y. I know from my previous lesson I'm going to put those together. So these are actually going to represent the solution set, okay, the values that prove true for this equation, 9x plus 3y equals 18. The y-intercept for this line is 0 and 6. Once I've identified that point, I want to plot it. So I'm going to go to my origin of 0, 0. I'm going to move to an x of 0 and a y of 6. Plot my point. Let's see you try your x-intercept. Setting my paper up over on the right, go ahead and determine what x equals when y is 0. Yep, so when when y is 0, x is actually going to be equal to 2. Take a look at any of the steps. Rewatch if you need. All right, so the solution set for this ordered pair, solution set for the x-intercept is going to be 2 and 0. So I'm going to plot 2 and 0 on the line, and I'm going to connect those points. So I have handled prompt 1. Let's go ahead to part A. Now I want to sketch the graph of the equation y equals negative 3x plus 6 on the same coordinate plane. So I'm locating the same graph, but there are some different processes that I need to plot a graph in y equals mx plus b form. If I have been given a graph in standard form, I need to know an x or I need to know a y to begin to find my ordered pairs.
If I have been given a graph in standard form, I need to know an x or I need to know a y to begin to find my ordered pairs.
If I have been given an equation in slope-intercept form, I have already been given all of the information I need to begin graphing. I start by plotting my first known point, which is what? I'm going to start by plotting my first known point, which is my slope intercept. And I know particularly from this equation, okay, so I'm going to write it up here at the top of the page. The equation we're working with is y equals a negative 3x plus 6. I know my y-intercept of this equation is going to be 0 and 6. I know my y-intercept is 0 and 6, so I'm going to go to 0 and 6. I'm going to plot that point using a different color so you can see. So I'm plotting 2 points on top of each other. Then I want to use my slope. I want to use my slope to move from one point to another. Because my slope is negative, that tells me that I'll be moving down instead of up. So I'm going to move down 1 point, 2 point, 3 points, and I'm going to move to the right 1 point. What do you notice about the second point I just plotted? Yeah, you should notice that it's also a point on the line. Let's look at question B. Question B asks, what do you notice about the graphs of 9x plus 3y equals 18 and y equals negative 3x plus 6? Why do you think you notice that? Type your answer in the box. Yeah, you should notice that the equations produce the same line. The equations produce the same line, even though they are in different forms. And I can verify that the equations produce the same lines because they go through the same points. And remember from lessons 18 and 19, there's only one line that goes through two of the same given points. So I want to rewrite y equals negative 3x plus 6 in standard form. Remember, standard form has our ax plus by on the left and our constant c on the right. When I look at my problem, I notice the variables x and y are not on the left side of my equation. What property of equality would I need to use to move the negative 3x from the right side of the equation to the left side of the equation? I would need to use the addition property of equality. So I'm going to add this 3x to both sides. When I add this 3x to both sides, on my right, my 3x's cancel out, and I'm left with just the 6. And on the right now, I have 3x plus y equals 6. Part D says, identify the constants A, B, and C in the equation from part C. So I'm going to go to the equation that I produced in part C. And I see that my A, my B, and my C, okay, my A is attached to the variable X, so my A is going to be 3. My B is attached to the variable Y, so my B is going to be a 1. Okay? And my C is to the right side of the equal sign by itself, so my C will be a 6. Part E, try that by yourself. Identify the constants of the equation 9x plus 3y equals 18 as A prime, B prime, and C prime. Those constants are 9, 3, and 18. Let's look at prompt F. What do you notice about A prime divided by A? Let's figure that out. So I notice when I put A prime, 9, divided by A of 3, I simplify to the whole number 3. I notice when I do B prime 3 divided by B of 3, B of 1, I simplify to the whole number 3. Try out C. When I put C prime 18 over C of 6, I simplify to the whole number of 3. So I notice that when I take the constants in the original standard form and I divide them by the constants in the transformed y equal mx plus b standard form, that I would get the same value of 3. Let's look at example number 2. Example number 2 works Number 2. The graphs of the equation y equals 2/3 x minus 4 and the 6x minus 9y equals 36 are the same line. That means what about this line? Yep, it means they're going to go through 2 of the same points and they have the same slope. Let's rewrite the first equation in standard form. So I'm going to write the equation like I've been given. And I know I want my x term and my y term on the exact same side. So if I want to move a 2/3 x from the right of the equation to the left of the equation, what would I need to do? I would need to subtract 2/3 x from the right side and subtract 2/3 x from the left side of the equation. So on my right side, they're going to cancel out. And on my left now, I have a negative 2/3 x plus y equals a negative 4. To rearrange or rewrite this equation to get rid of the fraction like we did yesterday. What if I wanted to eliminate a fraction from the left side of my equation? What would I need to multiply my left side by and my right side by to eliminate this fraction? I would need to multiply by the denominator. So my denominator happens to be 3. So now I'm going to multiply both my left and my right by 3. Okay, so I can almost be done, but let's track back to some earlier lessons. What do you notice about this form? Are any of our terms negative? How could I rewrite this equation so that my constant for A is not negative? I could multiply each term by negative 1. So I'm going to come over to the right because I'm running out of space. I'm going to rewrite this with negative 2x plus 3y equals negative 12. When I multiply my left side by a negative 1 and my right side by a negative 1, I am actually making sure that the opposite of every term is produced. You should have noted that each fraction was equal to the exact same constant. Multiply that constant by the standard form of the equation from part A. What do you notice? So I'm taking my equation in part A. 2x minus 3y equals 12. And now I want to multiply the constant, okay, that same constant that they are reduced to when I put a prime 6 over a of 2, it reduces to 3, and I multiply by 3. I produce 6x minus 9y equals 36. Exact same equation I was working with in part